semester, we have been working with the City of Alpharetta and the Metropolitan North Georgia Water Planning District to initiate a program throughout Alpharetta, Georgia that's goal is to depave and rewild impervious surfaces. Depave is a program that originated in Portland, Oregon, promoting the removal of underutilized impervious surfaces and has a focus on bringing together the local community through volunteering and public engagement events. The main benefit of depave is that it reduces stormwater. It also sequesters carbon and lowers ambient temperatures. Local benefits of depave include promoting community involvement through learning opportunities and increased outdoor amenities. Our project's purpose is to demonstrate the feasibility of depaving areas, showing the usefulness of creating green spaces from underutilized impervious areas and incorporating stormwater control measures and functional amenities. The ultimate goal of this pilot is to begin the depave initiative in Alpharetta and bring it to a local level by educating and empowering property owners to depave their own land. To begin our pilot study of depave, we selected a variety of sites in Alpharetta, Georgia. Through GIS exploration, we identified potential sites based on ownership, size of site, percent of impervious area, and any drainage or stormwater issues that they might have, which would indicate that they're a good candidate for depave. Here you can see a list of 7 sites that we visited based on our initial GIS exploration. After our site visit, we created a more stringent ranking criteria in order to pick the best site for our project. We weighted site area versus impervious area, stormwater conditions, available parking removal space, soil information, site maintenance effort, and accessibility. After the rankings, we picked Amana Academy as our site, which is a public charter school about a mile southwest of Alpharetta's city center. As you can see, the school already had a striped-off area of parking lot ready to be depaved, as well as an existing bioretention pond that shows a step towards stormwater runoff solutions. Here are some pictures from our site visit showing the striped lot. After choosing Amana Academy as our site, we began a hydrological analysis of the site conditions, including pre-existing storm drains, detention ponds, and drainage basins that we determined through flow patterns on the site. With this information, we had to calculate the runoff volume of both pre-construction and post-construction conditions in order to reaffirm that depaving the area would indeed decrease stormwater runoff. Our calculations confirmed that depaving this site area would reduce the runoff rate, measured in cubic feet per second, for all frequency storm events. While we proved that simply depaving the area would aid greatly in runoff volume reductions, the depave program is about creating a community space through the use of functional amenities and incorporating stormwater control measures, or SCMs, which are used to control rainwater runoff on a site. SCMs address flooding issues, local stream pollution, and erosion. SCMs have the option to be considered green infrastructure, which emulates natural water management processes. After the pavement demolition, we decided to incorporate 4 green SCMs, a green roof, a rain garden, permeable pavers, and rock swales. A rain garden is a depression in the earth with specific plants intended to temporarily hold rainwater and allow it to soak into the ground. We decided to place the rain garden in the middle of our site. Here's a side view of our rain garden. Rock swales are a form of bioslope designed to slow water flow down the site. We added them along the length of the site to form a boundary between the site and the driving corridors on either side, for both aesthetic and safety reasons. Here's a side view of our rock swale. Next, our main SCM is the green roof, which is a retrofitted roof with plants and soil material on top used to absorb rainwater. We decided to implement a green roof pavilion so that it could double as an outdoor classroom and recreational area, which Amana Academy was lacking. Here's a side view of our green roof. Finally, the last SCM we decided to incorporate are permeable pavers, which is a form of walkable surface designed to allow rainwater to penetrate into the ground instead of pooling on the surface. We incorporated the permeable pavers into a walkway that went from one side of the site to the other, stopping along the rain garden, green roof, and pre-existing bioretention. Here's a side view of the permeable pavers. For the site amenities, which would help increase community engagement, we have a walking path that incorporates benches and a bike rack along the pavers. The outdoor classroom will be positioned under the green roof and will include 12 tables with benches, a whiteboard, a teacher's desk, and 2 hopscotch courts. The green roof and rain garden plants will host native and perennial species, and an ADA accessible ramp will be added to the bridge over the existing bioretention pond in order to promote equality and safety. As per the Georgia Stormwater Management Manual and the Alpharetta Stormwater Policy Handbook, code requires a runoff reduction target volume for 1 inch of rainfall. So we calculated our storage volume for all 4 SCMs and affirmed that it was greater than the calculated target volume of 0.1037 acre-feet, deeming our stormwater management system as acceptable. A key part of the DPAVE initiative is the public engagement element, which takes into account the target audience and how to educate them. We decided to educate the students at Amana Academy through informational plaques next to each of the SCMs. Here are the four plaque designs, which each have child-appropriate language explaining the benefits of each SCM and is captivating to children through their colors and designs. We prepared a cost analysis of the entire process and deduced a capital cost of $395,000, including demolition and grading, materials, installation, and maintenance. This cost may seem infeasible for many entities to perform on their personal land, but much of this cost is due to labor. Since part of the DPAVE initiative is to work on volunteer-based projects, over a third of the cost can be saved by employing volunteer work. In addition to this, the community aspect of this project lends itself to potential discounts or even complimentary materials from local businesses.